We have a problem for you, kind of a wordy problem, and I'll just go right down to the statement of the problem. It says find the largest natural number not exceeding this expression here, this binomial. And so this is the binomial 3 plus root 7 quantity squared. We're supposed to find out what the floor is, and what they mean by that is find the largest natural number, in this case, that does not exceed whatever this happens to be. And of course, you're not supposed to use your calculator. Now, what I'm trying to get across today is this right here is equivalent to this. This is called the floor of the expression. This floor, these half square brackets, I guess you would call them. That's called the floor function notation, and it's a way to replace all of this wordiness. Now, this is a good phrase, but it's find the largest natural number not exceeding. It's well stated, but it's 1, 2, 3, 4, 5, 6, 7 words. And you can replace it with this if you understand that the floor function is a function with properties. Now let's just get back. Again, the floor function takes any expression whatsoever and maps it to an integer. For example, if question mark was equal to 4.6, the floor of 4.6 would be 4. Or if the floor of pi would be 3. Pi is approximated by 3.14. It has a fractional part of 0.14. And so the floor is always going to map to a natural number or an integer, and that includes 0. All right, now there's a property we're going to use in today's question that says the floor of x, where x is a real number, plus b, an integer, is always equal to just the floor of x plus the integer. That's very easy to believe. You know, the integer is not going to affect the computation on x, but this is a proof. The floor of x plus b. Now, x is composed of its own floor, all right, and its fractional part. So the floor of x, in the example I just gave, 3.6, this would be 3, and this would be 0.6. This is the fractional piece, okay? And so this part here, this part, and this part, the floor of x plus b is going to be an integer, and this part's going to be the fractional part. So the greatest integer, less than all of this stuff that I'm highlighting, is just going to be the floor of x plus b. Again, floor of x by definition is an integer. B is given to be an integer. So this is a quick little proof on why this fairly obvious statement is true. Okay, now let's get down to solving the problem. All right, so notice I used the floor notation all the way through rather than using these words. Now this is just arithmetic, binomial arithmetic. If you expand out this guy right here, 3 squared is certainly 9. The square root of 7 squared is certainly the 7 you see here. And then by the properties of the distributive property, basically is 3 times root 7 is going to happen twice. So that would be 6 times here. Now notice I grouped this 9 plus 7 into the 16. And at this point, I appeal to this property right here. You see how the 16 just comes out. Isn't that nice? And it's kind of convenient, right? The 16 just comes out of the floor operator. Okay. And now we're left with, now I rewrote this in one step. To bring the 6 inside the radical, we have to square it. And so that's 6 squared inside the radical. And notice this is just equality all the way through. Now, anyway, this expression right here turns out to be equal to 252. When you do 6 squared, I think it's 36 times 7, that ends up being 252. But we get a quick resolution to the problem here. The answer has to be 31 because the square root of 252 is bounded below by 15. 15 squared is 225. 16 squared is 256. Okay, and so you get 225 is less than 252, is less than 256 if you square this. Okay, y'all, I hope that helped.